Okay. Let's look at parabolas some more. I'm going to write the same equation from before. We've found how to find the x and y intercepts. But a lot of times we want to know where the vertex is. So we're going to look at finding the vertex and writing this equation in vertex form. This is the one we looked at last time. You may recall. Crosses at, what is it, 1/3 here, and way over at 2, -2. So its vertex is somewhere down here. It's, since this 1/3's here, this, if it was right here, it would be halfway between. It's a little less. It's going to be between -1 and 0 somewhere. Vertex. Don't know how far down. But if we have the vertex of a parabola, that's a very important point. That's where it changes from being decreasing to increasing, or increasing to decreasing. And a lot of times we want to look at the rate of change of a function and find where a function's slope is 0. So at the vertex, the slope is 0. And a lot of problems we want to solve, we want to find the minimum of a parabola or a maximum of a parabola if it opens up. So the vertex is very important. In fact, if we have the vertex and at any other point, we can completely graph the parabola. We know everything about it. Alright, so how do you find the vertex? Well, it's the formula for the x value of the vertex is really part of, remember, b squared plus or minus for the quadratic equation. Minus b plus or minus b squared minus 4ac. I hope you're happy with this plus or minus in here. It means there's two solutions. One is plus the square root, one is minus the square root over 2a. So actually this part here, this first part, is the x-coordinate of the vertex. You see, you're adding and subtracting this off, so you get your points are going to be symmetric, plus or minus something. You're adding the same amount back and forth, so actually your vertex is going to be in the middle of that. So you're not really learning a new formula for getting the vertex. The vertex, oops. The vertex's x-coordinate is minus b over 2a. So you can just look at it and write down what it is. Alright, that's how you find the vertex x-coordinate. So for the whole vertex, you want the x and y coordinates. Well, let's do that for this problem. Here, let's see, a equals 3, b equals 5. This is sort of the standard formula of a parabola. Is minus, c is minus 2. Don't forget the minus signs. They're very important. She'll get something very, very bad. Alright, so for our particular one, minus b would be minus 3 over 2 times a. Whoops. That wasn't b, that was a. So it's minus 5 over 2 times a, which is 3. So minus 5 over, so it's minus 5 over 6. That's the x-coordinate of our vertex. So we want the y-coordinate. So we want to know what y is when x is minus 5 over 6. I picked this because the numbers aren't terribly easy. They're not terribly hard. So let's find f of minus 5 over 6. Alright, so that's going to be 3. We're just plugging minus 5 over 6 wherever we see x. Minus 5 over 6 squared plus 5 minus 5 over 6 minus 2. Okay, remember to square this. So square minus 5 over 6, you'll get 25 over 36. The minus signs go away because it's squared. So it's 3. I'm going to leave it as 25 over 36. Not a wonderful number, but that's what we got. So 5 times minus 5 over 6. So this is minus 25 over 6. And I see a bit of symmetry here. Minus 2. Alright, that's our number. Let's get it looking a little better. Let's see. These both have a 3 in the top and 3 in the bottom, so I'm going to rewrite this as 25 over 12. Hopefully you're happy with that. So let's put this over 12. I have to multiply top and bottom by 2. It's just your old algebra skills. And so we can add them all together. Let's change 2 over 12. So multiply top and bottom by 12. We get minus 24 over 12. So now they're all over 12. We can add these things together. Let's see, 25 over 12 minus 24 over 12 is plus 1/12 minus 50/12, so that's minus 49 over 12. Interesting, there's 49 here, the square root of 7 squared. Where does 7 come from in all this? Interesting. So that's our y value. So our point, our vertex, I don't know how I push this down, but it's kind of neat. 5 over 6 is our x value, and 49 minus 49 over 12. 49 over 12. See, that's roughly 48 over 12 minus 4. So this was, remember we had that, I think we had the point minus 1 minus 4. So it's very close to that. It's on this side of that. So minus 5, 6, down minus 49 over 12. It's going to be here. I forgot where this crossed the axis. I guess it was minus 2. This is about minus 4, a little past minus 4. So this is our parabola. With a point and the vertex, you've got the whole thing through symmetry. Okay? So that's finding the vertex. There's also the vertex is so important. We sometimes want to be able to look at it and see what the vertex is. I'm going to write the same function again. There's another way to write this. What was it? 3x squared. What was it? Plus 5x minus 2. Its vertex is at minus 5x, 5 over 6, minus 49 over 12. There's a vertex form of this, which this is the a x squared plus b x plus c form. There's also a vertex form, which is nice because you can look at it and you can read off what the vertex is. You don't have to do any calculations to get the vertex. And the vertex form of a parabola is a, some constant a. It's a different a than that one. I don't like that we use a, but we do. X minus h squared. I'm worried about this a. Don't confuse that with the other a. Plus k. And here h and k are the vertex. The point hk is the vertex. So if it's in this form, you can look at it and say, oh, the vertex is minus, is the opposite of whatever's in there, and this in there. So we can almost write down the vertex form. A. We don't know what A is yet. I'm wondering if your book uses A. I'm going to leave A. Just be sure to know that this A is not that A. Alright. A is just a number. Alright. So we'll write down, we know what our vertex is, so it's minus 5 over 6 is h. So minus h is plus 5 over 6. A lot of people are going to miss this minus sign or not put it in right. Plus k. Plus, and it turns out our k is negative, so I'll just say plus minus 49 over 12. And that's our function almost. We still don't have this a value. We can take any point of the function and put it in to solve for a. Let's do that. We may call this y, of course, if we're graphing it. Y equals blah, 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 blah. So we can look at this and say, the vertex is at minus 5 over 6. Change the sign here. Minus 49 over 12. That's our vertex or parabola. Notice that if you have a parabola and you say it goes through this point, and if this is this a controls how wide it is. There's lots of parabolas that have their vertex there. Here's one. Here's a very pointy one. Here's one that goes with the negative thing. So there's a whole family of parabolas that go through that point. There's a very wide one. That a controls how wide it is and whether it goes up or down. If the a is negative, then it goes down. If the a is positive, it goes up. Let's just solve for that a. Let's choose a point. We could pick 0. I remember we had minus 2, 0, which we had from solving this for 0. I'm going to use that just for fun. So that means that at that point, y equals 0 when it's a, let's see, x, when x is minus 2, so it's minus 2 plus 5 over 6 squared minus 49 over 12. I'm a little worried that I picked a difficult number. Let's see. Minus 2 is minus 12 over 6 plus 5 over 6. Gives you minus 7 over 6. Oh, the 7 is back. Just regular vanilla algebra here. That's squared. Interesting numbers coming up here. You can see the 7 figures heavily in here. 49 is 7 squared. Alright, let's square that now. Square makes the minus sign go away. 0 equals a times 49 over 36 minus 49 over 12. So I'm running out of room here. Let's see. This all equals 0. I'm going to move that to the other side and then just wave my hand and say a times 49 over 36 equals 49 over 12. Let's see. These are the same. This is 3 times that. So if a was 3, this would work out. So a here equals 3. Now I'm extra worried because this a actually worked out to be the same as that. And that's not terribly surprising. If we multiply this out, our only x squared term is going to be ax squared. And that's going to have to match up with this. So actually, that is the same a. It's not exciting. Okay, but you can always solve for a by putting a point in. Alright, so that's our final equation. This equation, written differently and much smaller, is 3x plus 5 over 6 squared minus 49 over 12. You can look at it and say, aha, this vertex is at minus 5 over 6, comma, minus 49 over 12. And you can quickly plot that point. Use another point, maybe where it crosses the y-axis, minus 2, and you can graph your whole parabola. A lot of times we will be asked to take a equation in this form and write it in this form, which which means you find the vertex, plug those in, and solve for A. Maybe you don't have to solve for A, maybe you can just look at it and see. Okay, neat stuff. Parabolas, they work out nicely. That's about everything you need to know about parabolas. Isn't that wonderful? Okay.